Hi there, this is Math 145, Section 3.1 Notes. And what we are dealing with here is what they call measures of central tendency. And what we're really talking about is if we have a data set, right? So let's say we collected household incomes from 100 different households, or the ages of people in our classroom, or maybe I'm talking about the scores on the last exam. Right? It could be heights of giraffes in the Serengeti, whatever. We have this data set. Now, how can we summarize it to get a bigger picture, right? How can we really start analyzing this data that we have? So in 3.1, we're going to look at the center of data. And there's two main ways that we measure the center of the data. They are the mean, which is usually what you call average, but not always. And we're going to talk about that word average a little bit as well. And then you have the median, which is the middle number of the data. If you line up all your data in increasing order and pick out the middle number, that's the median. And the third thing that's actually put in here, but is technically not a measure of center, is the mode. And it's just the most common value. We'll see that a little bit near the end of the notes. So let's jump right in here and look at the arithmetic mean, or simply called the mean. Go ahead and read over this, answer that question, and then we'll move down with that notation stuff together. So pause me down, though, and read over those guys there. Okay, so like it says here, to find the mean, you just add up all the values and then divide by how many ever numbers you had. And then we have two means, technically, because we could have our data from a population, and if we take the mean of that data, we're going to call it mu. That is, again, pronounced mu. It is a Greek letter, that thing. And then if the data is from a sample, you have to be able to denote that. And so we're going to call that x bar, pronounced up there for you. So the question here, which is considered a parameter and which is a statistic, you may remember those words from chapter 1. Parameter meant it was from population data, and statistic meant it was from sample data. So that's how I remember P and P, S and S. And so what we would say is X bar is a statistic that is in fact trying to estimate mu, the parameter. Now, going on with this notation, as I said, the definition up here says you add up all the values and divide by how many ever you had. So let's put that into the notation that we had with population and sample sizes. If it's population data, here we start here. If it's population data, you're going to call it mu. You're going to add them all up and divide by how many you had. Remember that capital N was the population size, or the number of elements in the population. So you've got your elements, x1, x2, all the way through x sub capital N, meaning the different data values. So if I had, say, 20 people in my class and that was my population, I would have x sub 1, maybe their age, x sub 2, the next person's age, all the way up through the 20th person, whose age would be x sub n, or x sub 20. Now, this here is shorthand notation. It means add. It is the Greek letter sigma, as it says down here, and it simply says add up all these x sub whatevers and then divide by how many you had. So that's just shorthand. You're going to see that, and also get used to it here, because when we get to 3.2, we're going to see that sigma notation with a lot more complicated stuff to do. So if you get used to it here, it feels a little bit better to us. And then what we've got is down here, what if it was a sample? What if this data was from a sample? So then I would be finding x bar, because that's the notation for the mean of sample data. And lowercase n, you'll remember, was the sample size. And the notation just simply says add them all up, divide by the number of numbers you had. And shorthand notation with the sigma notation is there. One little thought bubble there tells us what we want to round to. If MyMathLab does not tell you, or if you're out in the real world and actually doing data, you want to round to one more decimal place than that in the raw data. So we'll see that as we go. Oh, and one last little bit here. To find the mean, the data must be quantitative, meaning you have to get numbers from people, right? You can't average the answers to what's your favorite movie. That would be qualitative data, as we saw a distinction back in chapter 1. So moving on. Why don't you go ahead and try to do all of 1A and B. Pause me down. Look very carefully at the wording of the problem to make sure you answer that second question on part A correctly. But again, pause me down, do it all, 1A and 1B, and then come back. Okay, so here's my number 1. I did notice that this was the data was the travel times to work in minutes for all 7 employees of a company. So when I figured out their mean, I labeled it mu because I felt like all 7 employees of that company was a population, as opposed to down here in letter B when I sampled from that population. So I called it, back up here to A, I called it mu. I, of course, added them all up there, and I divided by the number I had. And I had to round this, 24.9, and I also attached the word minutes on that. That's an important label to not forget. Also, I want you to notice that I have an approximately equal sign here because I did round. And it is important to keep note of if a number's equal or approximately equal to what you wrote down. So that's just good habit to get into. And, I want to also point out that the decimal places in the original data were whole numbers. So my thought bubble at the bottom of page 1 told me to round to one more decimal place than I had in my raw data. And since the raw data had no decimal places, because they were whole numbers, then I put 1 decimal place down there when I rounded. So that is part A. And then part B says I sampled 4 of those people, and I got those numbers. I added them up. I divided by 4. Again, I'm sampling, so I called it X bar. And it was exactly equal to 23.5. I did not have to round here, so you'll notice my equal sign. You will, of course, also notice the fact that I put minutes on there. Very important detail. So go ahead and next off, read that definition. And why don't you try number 2? And then we'll talk about that other stuff together. Pause me down. Okay, so for number 2, I did what it said to do. It said line up the data in increasing order. So I've got my data here, and I'm just going to pick out the middle number. And if you've got more than so many values, it's kind of helpful maybe sometimes to cross off. Some people like to do this, cross off the outsides, and then I'll cross off those 2, and just kind of working my way on into the middle. And lo and behold, I have my median there at 23. Call it capital M, or write out the word median, of course. You could do that. Oh, let's not forget the units. That's 23 minutes, isn't it? So that's that problem. And there is some discussion in these notes about the word average. And I just want to kind of introduce that idea here. Sometimes when people use the word average, they are talking about the mean. And sometimes they are talking about the median. And sometimes they use the word average because they know that might be confusing and they're trying to manipulate you. So you do have to be careful of that. And we'll talk about a couple examples of that. Often, more digging is required to see what they actually did intend. Are they talking about the mean or are they talking about the median? So that's interesting to think about. Also, just like the mean, to find the median of a set of numbers, you have to have numbers. They have to be quantitative. And again, it doesn't make any sense to try to find the middle number of the answers to what's your favorite movie. So let's move on from there. Okay, so number 3 supposes that an 8th person joins this development company. And so I want to find the median now. So go ahead and do that. Pause me down, of course. Do that. Line them all up and see what the middle number is. There is no middle number. So what do you think you should do? Go with your gut. Okay, so here I wrote all those numbers out, and notice all I did was, to make that problem, I just added a 33, so that went in there in its place. And so again, I'm just going to mark them off from the outsides and work my way toward the middle. And wait a minute, I've got 2 numbers in the middle. So how do I find the middle number? Well, maybe your gut tells you what my gut says, and that says, hey, why don't you find the middle of those 2 numbers? Find the number right there in the middle of 23 and 26. And that's basically what the process is. And that is essentially averaging those 2 numbers in the middle. So I'm going to add 23 and 26 together, divide by 2. What's that? 49 divided by 2, and that should be 24 and a half, shouldn't it? So let's throw a units on that. Never forget the units. Again, noticing my equal sign because I never rounded there. And there is how to find the median if I have no middle number. Simply average the middle 2. Why don't you read over number A just so you kind of have an idea of where we're going with that. But you'll notice we're going to do this on the calculator, so I'll be getting out of video. So pause me down, read that over, and then come back. Okay, so like it says, here are the 10 salaries of some employees at a company. So I'm going to find the mean and the median, putting that data into the calculator, and then telling it, go do my calculations for me. And so let's see the video. Okay, so those are just the calculations that I used for finding the population mean and the sample mean from the last problem. And I'm going to hit that stat button. That is up here near the top of the screen, but right up here, stat. And then I want to edit up top, and number 1, edit, highlighted there on the menu. And so of course I'm going to hit enter. Now I personally have some other stuff in L1 and L2 that I want to get rid of. And so I'm going to arrow all the way up to L1, and I'm highlighting L1 itself, you'll notice, and I'm going to hit clear. And then when I go back down with the arrow buttons, notice it's all gone. So I'm going to do that same thing for L2, clear, and then all my data is gone. Now, I am going to put my 10 salaries in there, hitting enter after each one. So that, I'm going to pause the video. All right, so starting up again, I'm at the bottom of my list. I have put in all of the ones, the numbers. Notice the last one is 200,000, so make sure you get that in properly. And I also noticed that I hit enter after that last entry, and I noticed that I'm on element 11. Do you see that little 11 down there? And that's just a quick reminder that I have put in the correct number of numbers. I had 10 salaries and I put in 10 because now I'm on the 11th line. So that's kind of a nice check. Now let's tell it, find me the mean and find me the median. It's all in one whole output. So I'm going to hit the stat button again. Technically you could quit, second quit out of there. You know, usually I like to do that. Technically you can just hit the stat button from there, but now I'm going to hit the stat button. And this time I want to go over to calc for calculate. And then it's simply this one var stats, or one variable stats, that I want. So I'm going to hit enter. And it goes that goes onto the home screen. I hit enter again to actually say, yes, do this. Now let's talk through this. Now, X bar up there at the top is 46,300. Put a dollar sign on that, of course, when you write it down, but that is your mean. You also have sigma x's. It added up all those values that we put in. Sigma x squares, it added up the squares of all those values. So those two things you never really need in this class, but they are in case you wanted to calculate standard deviation by hand. We don't really need to do that in this class. SX and this sigma x, this weird looking, that's also sigma, believe it or not. That's just a lowercase sigma there. Those are standard deviations. We'll talk about those in the next section. You have n equals 10, which is another reminder that you put in 10 numbers, and you have the down arrow. And the down arrow means there's more stuff down there. And so if you arrow down, you'll see that there is indeed more stuff down there. Now, none of that is relevant for us right now, except for the med, or the median, is 29,000. So what we are going to pull out is the X bar at 46,300, and then down there with the median at 29,000. So I'm going to stop this video and then we'll go back to the notes. Okay guys, if you do have a newer calculator than me, you probably found an intermediate screen in there. And I do have some mention of that right there in that parenthetical remark. And let's see. We looked for X bar, which is the mean. Now, just to be clear, the calculator will call this X bar even if you know the data is from a population. So if I was really doing a statistical paper and I knew this data was population data, I would definitely be calling it mu. But in this case, for this example, it doesn't much matter. I'm just going to write it down as X bar. And you'll notice I did put a dollar sign and a comma to make it more readable and to put units on it, which is always very important to keep in mind. As you arrow down there, you find the median or the med. And again, that was 29,000. We got that from the video. So there's that. Why don't you go ahead and think through these problems, 4B, 4C, and 4D. Pause me down and then come back to me and we'll talk. Okay, so for 4B, they were asking me if I wanted to stress the company's great salaries to prospective employees, which average would you provide? And so I was thinking about how the word average could be used to describe the mean, but it also could be describing the median. You just don't know unless you're told specifically. But if I wanted to stress the great salaries at my company, and maybe I didn't care so much about being truthful, I'd tell them that the average was 46,300. That feels a whole lot more impressive, doesn't it, than telling them the median salary is 29,000. On number 4C, it says, why do you think the mean and median are so different? And for that, I have this list of numbers down here that I just listed out all of those salaries down there so I could explain what I mean by this. But here's what my thinking is. The mean took that $200,000 into the total. Remember, the mean would add up all of those values and then divide by 10. And so that value increased the mean quite a bit. The median, however, just used the 200,000 as the highest value. And it got struck off as we made our way to the median. Remember, again, how I would find the median of this by hand. I'd be like, well, here I'm labeling them all out. And then I'm going to knock off those. And look at that, the 200,000 is just gone. It was just the highest number that just got knocked off with the lowest number, didn't it? And I'm here in defining the median. See that? So, in fact, this 200,000 made hardly no difference at all in finding the median. It just needed to be 36,000 or more, and I'd have the exact same median, wouldn't I? 4D is really there because I want to point out that that is an outlier. That 200,000 is so much bigger than the rest of the data that we call it an outlier. And just, maybe it's the boss's salary. There we go. Now, look at this definition of resistant. A numerical summary of data is said to be resistant if extreme values, either very large or very small, relative to the data, do not affect its value substantially. So, do you remember how the 200,000 affected the mean quite a lot, but the median, not much at all? So, here we are trying to say medians are resistant and means are not. Okay, so here on number 5, we're still talking about means versus medians and outliers perhaps, but more so the distribution of a variable, right? Is this data skewed or symmetric? That's the distribution of the variable. So look at number 5 here. It tells you that this is the asking prices of homes in dollars for sale in Lincoln, Nebraska at this time. I have already calculated for you the mean and the median there, so you don't have to bother doing that. I also give you a histogram of the data, and I want you to look at that histogram and describe the distribution. In other words, is it symmetric, skewed right, or skewed left? And then what I want you to do is think about how the mean is less resistant than the median. It's pulled up by large amounts, seen on the right of the histogram. To visualize that, I want you to draw vertical lines on the histogram to mark the mean and median, which again are given up here. Okay, so go ahead, pause me down and do that, and then come back. Okay, first off, I'm going to answer this question in the thought bubble. It says, which classes hold most of the data? And I'm kind of looking at this area where there's an awful lot of houses in that region. And so I'm going to go from 100,000, which is there, to 150,000, which is there, and maybe include that 175,000. If each class worth is 25,000, wouldn't that be 125,000 there, and then 175,000. So that's how I'm reading those numbers. And I'm saying in those 3 classes, it looks like there's an awful lot of the data. And in fact, when you go to the table, you get all of this data and all of that data and all of that data to about there. So that's an awful lot of the values. And you get a few other values there, really big values there. Not many of those houses are in that region. And so you get these short little guys here, right? And these short little guys on the right-hand side of the graph lead us to conclude that it is skewed right. So let me erase a little bit of that, and then I'm going to answer that last question there, which says to me, draw vertical lines on the histogram to mark the mean and median. And again, what we're just seeing here is that the mean is pulled up. So here's the mean at 168,320. That's there. And then if I want to mark the 148,000, that's about there. Not the greatest, but that's good enough for our purposes. That's that. And again, the idea being that these very large numbers at the end pulled up the mean, but didn't quite affect the median as much. Okay, so here we're talking about mode. So here we've got a definition, a little bit of terminology there, and then we've got number 6. Modes are technically, again, not a measure of central tendency, but they're always thrown into that section of any math book that has means and medians, it seems like. So read that over. Do number 6. It actually, I think, asks you to make a frequency chart. So remember, that's kind of like this, this here you have account, and you have like answers, and then you count the strongly disagrees, and then right, that disagrees, and etc. So go on with that, count them all up, and then determine the mode. And of course, pause me down and meet me back here. Okay, so just going through that definition, the mode is the most frequent observation that occurs. And if you happen to have two numbers that occur the most and none other, then you call it bimodal. More than two modes gets the name multimodal, although you don't see that a whole lot. And if no observation occurs more than once, we do say that there's no mode. You're not going to say everything is the mode. So, unlike means and medians, you can use this for qualitative data, which you'll see we did use that on example 6, which is qualitative data. So on number 6, Mr. Kramer gets a yearly evaluation from his students, and he's got 16 students, it looks like, and they either answered the question, the teacher is fair, by saying they strongly disagreed, neutral, or agreed, or strongly agreed. And so a frequency chart of that is just this guy here. And I simply counted the number of strongly disagrees in there, and disagrees and neutrals and so forth, and I got those. I did, by the way, make sure my total was in fact 16. That's a good check, just to make sure you're not missing anything. And I simply noticed that the one with the most counts was strongly agree, and there was my mode. And that's that. So go ahead and think about number 7, if you would please. Pause me down, see about it, and then come back. Okay, so for number 7, some people's first thought is just to add on the 0.65 in there, and then like divide it by 2, or maybe not divide at all. The reason we don't want to do that is because it gives that last frog too much prominence in that average. So we basically need to work with the original mean weight of the 13 frogs and work backwards from there a little bit. So I know the sum of the 13 frogs' weights, I didn't write the word weights in there, but that's what I mean, divided by 13 is equal to that 0.8. So if I multiply both sides of that by 13, I see that 10.4 ounces is the sum of the first 13 frogs. So what I want to do now is add on the 14th frog, which is 0.65 ounces, and refind the mean. So the sum of the 14 frogs together, again, all 13 plus the runaway, is 10.4 plus that 0.65, which was 11.05. And then if I divide that by 14, I get the average weight of all 14 frogs. And I had to round it. So once again, notice my approximately equal sign. It said round to the nearest hundredth place. So I did that at 0.79 ounces. Okay, number 8 wraps us up on this guy. This is, by the way, very similar to a homework problem, as was, by the way, number 7 on the last page. So I have 10 salamanders whose lengths I have measured. The data lined up just like this. Do part A for me. Why don't you go ahead and do part B? And I will say the very most important question is part C. Pause me down, do those problems, and then come back to me. Okay, so for part A, I am going to refigure the median, or as much as I could, right? So I'm going to strike off the 2 outside numbers. I'm going to strike off the next 2. I'm going to strike off the next 2. I'm going to strike off the next 2. And I notice I have 2 numbers on the inside there that I need to average, right, to find the median. So I know that the median is 14, but I also know it's 13 plus this unknown number divided by 2. And so I come up with that equation. And I'm going to solve it by multiplying both sides by 2. And then subtracting off that 13. And that gets me x equals 15. I'm going to put on a label on that. That's centimeters. And if I put in a 15 in there, and just to check myself, I think to myself, if 13 and 15 were the middle numbers, does it make sense that the median is 14? And yeah, it does. 14 is exactly in between 13 and 15. So I did it algebraically there with a quickie little thing. I should have written x equals the missing number right over here before I wrote my equation, but please forgive me. And let's do B. What's the mode of all 10 measurements? It certainly looks like there's 10, but also 16 and 16. Those both occur twice. So those are both modes. And remember, that word, it might come up from time to time, is bimodal. Okay. Oh my gosh, this is very important. Draw a picture of what you think salamander doo-doo looks like. I will let you go on the web to verify. This is kind of what I think. Yeah, a little bit like that. So you make sure you research this one very carefully. It's extremely important. This is extremely important. Don't take your homework lightly. You hear me? Okay. I'll see you later. Hey, shoot me an email if you have questions. Bye.